Greetings, my young calculus students. We are now going to take a look at what the derivative can tell us about an equation and how we can use it to find the slope of a tangent line. Hold on tight. The derivative does exactly what I said. It helps us to find the slope of a tangent line at any given point on a function. So for example, if I wanted to figure out what the slope of the tangent line of f of x when f of x is equal to x squared minus 3, at a particular point, 2, 1, I can use the derivative to help me find that out. So here's what I'm looking for. See this green line here? This green line is what I'm hoping to find the slope of. The red line is the curve x squared minus 3. This green line is the tangent line of the curve at the point 2, 1. You can see how it just touches the curve at that particular point. So how do we find that? We use that definition of the derivative like we just worked on in the last video. So let's write out that definition of the derivative. So f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x, that whole thing over delta x. We'll take that, we'll fill in our formula. So that will be x plus delta x squared minus 3, that's the first part, minus the actual equation itself, that whole thing over delta x. Now what do we do? Now let's see here, I'll simplify the top there. So I'll multiply out what I got there in my parentheses. Minus 3, I'll distribute my negative sign to those other parentheses. I'll make sure I got that all over delta x, and uh-oh, my error. I forgot my limit as delta x approaches 0. Let me put those there just in case I forgot them. All right. So now what? Let's see here. We got some things that cancel out. Let's see what cancels. The x squared cancels with that, and the minus 3 cancels with the plus 3. Keep going. We'll keep simplifying. The limit as delta x approaches 0 of 2x delta x plus delta x squared all over delta x. I'll factor out the delta x and divide it out, and I'll get the limit as delta x approaches 0 of 2x plus delta x, which when I simplify it down gives me 2x plus 0, or just plain old 2x. So I know that f prime of x is equal to 2x from this whole process. So now what? Well, let's see here. Let me give myself some more room. So I know that f prime of x is equal to 2x. So if I'm looking at the particular point 2, 1, the x value that I'm looking at here is 2. So what I can do is I can take that derivative and I can plug the value 2 into the derivative. What do I get? I get 4. So what does that tell me? That tells me everything I need to know. That tells me the slope of this line right here. The slope is equal to 4. And look at it. Look at it. If you counted, check it out. The rise is 4 units and it's over 1. And we do that again. We go up 4 and we go over 1 to get to that second point on that line. So that's exactly what the equation of that tangent line is. It's 4. How's this work? Well, what if I had a different line? What if, for example, I wanted to know about this line right here, this blue line? What do I know? Well, I would figure out what the x value is. Let's see here. What point is that? That is the point -1, -2. So if I wanted to figure out what the slope of that line is, all I would have to do is I would have to plug in -1 into my equation. Let's see here. What do I get? I get -2. And yeah, doesn't it look like that goes down 2 and then over 1? That's great. So my derivative can actually help me find the slope of any tangent line anywhere on this curve. If I wanted to go to the x value of 100, I could figure out what the slope of that tangent line is. If I wanted to figure out what the slope of this line is at -1.27358, I could. I just used the equation that I found, and I used the derivative of that equation. Pretty neat. That's basically it. So this section is really just a continuation of the last, where we're just adding one additional step to the problems that we were doing from the previous section. Here are your homework problems. Go take a look at those. And as always, if you have any questions, please let me know. Good luck.